All right, squad. So in today's video, I just want to run through a real world problem that we're having right now. So with Clipflow, we are storing all our video in our media files. Obviously, we handle a lot of media here. We store that in S3, right? So from the client, it gets uploaded directly into S3. And the process, the way it works is, I guess I can show you on a little diagram. Okay, so the way it works at the moment. So we have our client here. So this is the person with the file, right? Then we have our server up here, our instances, right? So we have our instances/app here, and that's multiple instances. And then what we have is we have S3 storing all our files. I might put that down here. Hopefully everyone can see that. So let me zoom in a bit. Now, what's going on? So the client does this, and here we goes, uploads the file. But before that happens, we make a request to the server here, and we get a pre-signed URL. Okay, so that we talk here in behind the scenes using active storage, pre-signed URL. Like this. So the way it works is before an upload happens, API will request a pre-signed URL. We're using multi-part upload, so it's a slightly different kind of flow, but we hit this app here. In Rails with active storage, we're going to generate a key that we're going to use, and as well as the pre-signed URL. We're going to pass that back down to the client here. The client's going to get that and then start the multi-part upload here, right? So we're going to do multi-part. I'm just going to write it down because it is slightly different because the files are so big. We need to hit them we break it down into chunks and we upload that, and we can saturate the bandwidth so we can get the fastest upload speed possible. And that sits in S3. When the upload is done, right? So it's actually handled on the client. So once we're also going to send it back here. And then we're going to say, this is a really bad diagram, but anyway, upload complete. From there, we now tell the server, right? So we upload the file to S3 here, goes. When it's done, API says, cool, the process is done. It tells the server. And then in the background, what we do with the server is we go and we link the file and the blob together so that Rails knows where the file is. So usually what you could do in the basic instance is you upload directly to the app and then the app passes it off to S3, but that just creates a double handling here. Whereas we want to just go straight to this. It's the fastest way possible. And then from there, we can just tell the app, hey, upload's done, link the attachment together, okay? That's the process. Now, we have to, from there, we run a background job, right? So we have, I don't know what this is, we go here. So we have workers, right? So these are our workers. So we need to extract thumbnails as well as metadata from the video files. So we do that in the background because if you run that on the main app instance, it uses a lot of memory and it can block and take down your app, right? So what we do is here we go and we say process video file, right? So we do that into the workers, and the workers then have to grab the file from here. It needs to download file so that it can actually process it, right? So it's just like you have to have a file on your computer. Think about it that way. So we need to go and fetch that file from S3 down to the workers. Now, the unfortunate part is this is in Fly.io and this is in AWS. Now, AWS is known for this, and a lot of the big cloud providers are, but you get charged for outgoing, let's see exactly what it's called. It's called data transfer out, right? So transferring into AWS is free, but transferring data out of AWS is not free. It's very, very expensive. Now, you can see there's a bit of a problem here because we are sending a lot of data out of S3 into Fly.io, which is not hosted inside of AWS. So we now incur a cost. Now, you can see here how this is growing. So you can see as we become so from August, pretty much nothing, as the data usage gets more and more, and all it is uploading of video, because every time someone uploads a video, we have to go and process the thumbnails. That means transferring data out to Fly.io. And you can see here in December, that rocketed up. And now for January, we're already past this because our usage is going up. And you can see here, it's quite ridiculous actually, because our data transfer equates to pretty much the entire bill. Like your data transfer in is $5.88 and your data transfer out is $41. The actual storage here is almost nothing. Like to actually store the data is very, very little. So you can see our transfer out's just growing over time. And then our actual time storage, like we've got here, is $2. And no usage type. Look, I don't even know what that is. So thanks for labeling that. But the rest of it is like, this is storage here as well. And these are the lower tiers, right? So we have like frequently accessed, which is FA, infrequently accessed, and then this is archived infrequently accessed, I believe, inside. So we're using intelligent tiering in S3 just to save costs. And you can see like we're spending $4 on storing an enormous amount of data, but we're spending $56 or $41 plus some more just transferring this data in and out, which is ridiculous. And that's just to grab a thumbnail and some metadata. So we've got a bit of a problem, okay? So that's the problem that we're facing, and we now need to solve it. So I'm just gonna walk through basically how I'm thinking about this and what I was thinking we should do. Now, obviously, the main problem here is that these are now sitting in different areas, right? And what I've researched is that Fly.io obviously they're running their own servers. They're not on top of AWS, or like a lot of cloud does, it sits on top of AWS. It keeps the data inside. They're not, from what I can see. So it means we're transferring files out. And a big problem as well is that the size of the file is enormous. So like we're talking, gigabytes minimum. So you're talking from 1 gig to 10 gig, 20 gig of data. Now we have to transfer that across the wire. So that could take minutes. So some of these jobs to extract the data takes minutes, and it's purely because it takes so long to transfer that file across. So the solutions that I'm thinking and playing with here are, there's a few solutions. One, you could use a Lambda. So as soon as the file hits S3, we trigger a Lambda to go and use FFmpeg to go and get that file and extract the data. And then we post that result via an API request back to our servers and do it that way and basically update the data. I haven't exactly seen how easy that is to do. It might be a bit of a challenge, but I'll show you. So inside of our database, if we jump into Clipflow, have a look, it's going to be in the blobs, I believe. It's where the data gets stored. It's where are you? So yeah, it's in here. So you can see inside of metadata, we've got this. So we can, so I'm assuming we could easily update a blob as long as we could find the right blob. We can see here, it's identified, the duration, the frame rate, the height, if it was analyzed, the video. So we can update, I'm sure we can update that. And then the other piece of the puzzle is also then doing the variant records, which is actually updating the thumbnail. So from there, it'll be oh, that's a crash. So we'll need to update, cheers brother. We'll have to update or add a new thumbnail file so that it knows that there's a thumbnail for it to fetch. It doesn't have to try and generate a new one because we don't want that to happen. But what I'm thinking with that is it feels like a hack. It feels like an interim step, because like if we do change the thumbnail size in the future, to re-trigger all of this stuff is going to be a bit of a pest and a pain. So I'd prefer if everything could just work inside the environment. And what I want to do is avoid that data transfer cost, and I also want to improve speed. Now, because I believe, and I can't tell you this as a fact, but Fly and AWS are probably in different data centers, most likely, or, that's what I'm guessing. I don't know. But when we use AWS resources, they're generally co-located quite close to each other, so the transfer between is quite fast. And I'm hoping we can even get an improvement on how long it takes, because that will mean we'll get an improvement on speed and we'll get no data transfer costs, because that's going to kill it. Like we've got a handful of high using customers. When that turns into hundreds or thousands, that bill's going to get ridiculous, and it's really for no reason, right? So we're going to try and get rid of that. Now, so we can either go and do manual, set up all the different resources in AWS manually, or use something like CloudFormation, or automate it. But in the end of the day, we're going to be controlling the infra, which is a bit annoying. Like we just want to build the app. We don't want to worry about that so much. We can look at that later, but not now. And that's why we use Fly, because Fly just automates all those things. But what I have used in the past, and something that I want to try and investigate again, is flight control. So these guys are really cool. I've done a video on them before. But what they do is they add the platform as a service layer on top of your own AWS account. So you control all your resources in the end of the day. You pay your own AWS bill. They just add a little margin on top, which is basically a management fee, right? Like, so for a startup, 5 services, then $15 a service, you get 25 users, unlimited projects, unlimited environments, unlimited deployments, right? That's very attractive, because that takes out all the pain, and it's all like via a UI. And then we can just pay the AWS resources. So it's $79. Like that is, if I'm assuming this is US, it's pretty much the same as what we're paying for data transfer, but it'll be way more flexible, and that'll be the cap. We won't have to go and spend more and more, right? So this for me is looking really interesting. So I'm gonna walk through setting this up and see how easy it is to deploy our current app with flight control to AWS. Okay, so first things first, jump to the dashboard. Once you have an account, I've got 2 orgs here. I've got Greek Consulting and I've got Clipflow. Okay, so what we want to create is a project. And now we need to re-authenticate GitHub. And we want to authorize flight control ops. Yep. And let's see what we got. So we're going to use the Clipflow repo, and the environment name is production. I like this as well because I was really keen to start setting up a staging environment, and that was a little bit different. I mean, you can do it in Fly, let's be honest. I just haven't looked at it. So we're going to go production. The branch for now is going to be main, but I will change that, and hopefully you can change it, because you don't really want to be pushing to production from main. You probably want to push from production. So you know what? Let's do a staging. Let's start with a staging environment first, because then we can use the main branch. And then default push trigger is push. And now what we want to do is we want to use AWS Sydney, but we need to add our AWS account. All right, so let's do that. AWS account name. We only have a production one. So, you know what we could do? Let's go Clipflow staging, because we'll use a stage. Don't have a staging bucket, so we'll have to see. Let's go Clipflow production. I'm gonna have to go back, so close this, make that production, leave that there. Okay, let's just keep going with this one. So this is Clipflow production. Okay, I have admin access, open AWS with this link. So I've got to log into the account. Okay, so I've got my AWS account here, and then it says log into AWS, open AWS with this link. Let's see what happens. Okay, so it's launching CloudFormation, and it's using, so basically this is what we would have to set up. We'd have to set up our own CloudFormation template. So this is flight control. Does it say we have to do anything here? Creating this CloudFormation stack gives flight control secure, cross-account access assume role, provoke access in our dashboard or manually deleting the stack. Connecting your account is free. The stack must be created in US East 1. Okay. So there's the flight control ID. Do not edit. That's the stack name. Okay, so I think we could probably leave most things here. Resource requires, I acknowledge it might create some, yep. Okay, create stack. All right, so it's busy creating. We don't want to give feedback right now. And our flight control is going to wait for this. So I'll just pause the video while we wait for this. From here, we jump back in. You can see here that yay, the AWS account was connected. Okay, so it's simple as that. Hit continue. We don't need to customize the VPC, but let's just see. Okay. Okay. We don't need to change that right now. Let's hit next. We're on Rails. So we just want, so it's running on Fargate. I want this in a file in my repo. Plus 17 a month for load balance. Okay, so it gives you the costs here. So this is like a rough estimate of ECS plus EC2 is a version of Kubernetes. It gives you advanced control of the cluster instance type and supports GPUs. It enables leverage reserved instances. You have to manage the instance size to ensure enough CPU and memory for your app. Auto scaling is 2 times slower. Yeah, let's go with simple to begin. Now, what we also want to do here is just make sure. So what kind of machines are we running? 2 gig memory, CPU 2. So we don't want to go any less than that. So that's 2 CPU, it's even $71 a month. Is that per instance? See, that's going to be quite a lot more. 2 gigabytes. But I mean, these machines are going to be way more powerful. So let me have a little quick think about this one. All right, so I'm just pulling up the Fly stuff. So we got 2 gigabyte CPU shared, 2 gigabyte with 2 CPUs shared. So we're paying $11 a month. Now I'm trying to understand how that works. 2 shared CPUs, what's the difference? Because this looks way more expensive. So if we go to AWS, have a look at, I mean, we could even look at AWS Fargate. Serverless compute. I don't want serverless. Really? Where is the pricing? Here we go. Linux, Asia Pacific, Sydney. Where per virtual CPU per hour? Per hour is 1.5 cents, and theirs is 5 cents. So it's quite a lot more there. Run interrupt tolerance, a spot instance. So one of this is more like ephemeral storage. But even then, we should look at, so if we look at this, change this, ECS, so that's plus $49. And that's $17 for a load balancer for NAT gateway. Oh, this is cool. So let's go Sydney, where are you? Ooh, Asia Pacific, it's Melbourne even. Sydney, Linux per month. So T3 medium. So the T3 small is $20. And that's 11. So why does that, let's go T3 small. What's, oh, the A. That's $19. And what's this one saying? $19. Okay, so that's probably more in line. 2 CPU, 2 gigabyte. And that's probably more in line with 2 CPU, 2 gigabyte, $11.39 and versus $19. So a little bit more, plus then you've got to pay this NAT gateway and load balancer. Now, obviously it looks like a little bit more expensive, And this is way more expensive. So if you jump into this style, $71, that's way too much. So we want this, we want to run a T3 medium. That's probably going to be fine for now. I like this because we can scale and we have a lot of flexibility here to change it in the future. Because I know that over time once you do some load testing, you can play with the different instance types to get the best bang for buck. Cluster minimum instances. I reckon this is at least 2. We're going to do 2 here. And then the maximum instances should be at least 2 times your max app instance. So let's just go with 10. So app vCPU, this is the cluster. Okay. So we have to run that, plus we have to run this. I wonder if you can change this. If you can rebuild. The trade-offs are that it does not support GPUs or custom instance types and can be up to 1.5 times more expensive. Okay. All right, so let's just go with let's go the default here, 1 minimum cluster instance here. Now the vCPU here, why can we only have 2? App memory in gigabytes, 2. Minimum 2, maximum 4. And this has to be double that, so that can be 8. Let's leave it at 10. And then the build configuration is Docker. For commands and Nixpac mono repo docs, we're going to use Dockerfile, and that's sitting here inside of our thing here. That's fine. Pre-deploy command, post-deploy, include environment variables. In build environment, auto-inject environment variables inside Dockerfile, watch path, build the type EC2. We're not going to touch that. Build the stage 30 gig. So this is just the builder, the network, custom domain. Now, do we have to fill that in? It looks probably. The internal port's 3000. So is this clipflow.co? Do we need that? Health check part. I think it's up. Let's just check. I mean, maybe this is actually living in our fly here. That's jobs, up. That's our up path. And that's grace, so timeout interval 10 seconds. Grace period, what's the grace period? So we can just copy these settings, right? So pull that across. We're gonna go 10. Health check timeout is 2. Health check interval is 10. And grace period is 5. All requests from clients do not enable a special requirement for this. CloudWatch retention, sidecar configuration, auto scaling, update service, Rails app. Now, background worker. Do you have to run each one of these? This is interesting. I thought you could run it in the same cluster. Have to have a look into this because you would think that you could run your workers inside your cluster. Add your services. So we've got our web server. I wanted a T3 small again. The worker CPU. So here we're running a 2 CPU 4 gig RAM. So we want more RAM here. Wow, they're definitely so we need more RAM here. Okay, so we can use up to 3.75 gig. Probably need 2 CPU here. Minimum worker 1, maximum worker 1. For now, that's fine. Docker file. Watch paths, EC2, logging. All right. So we got that. And these guys use 2 vCPU. And they use 2 gig. And then what we actually need then, we also need our Redis instance. We can do a micro for now. I'll just check what we're using in Fly. So we're actually using pretty much nothing. 2 gigabytes, so we don't even need like really. We could probably just connect to this direct. Probably keep using, because I think we're only using this right now for doing A/B testing. So we actually don't need that. I'm not going to spend money on that right now. So just cancel that. I'm sure we can add. So we need to add this flight control. I like having this. Here. So I'm going to just quickly add this code in. Okay, so I've dropped this in here now. So we're using the schema. We've got a production. So list environments, Rails app. So it's got it all here. Privileged, false. It's not allowed anymore. False. I probably just have an old plugin of Fly or something. So that's the worker. And that's the web. It's interesting there. You have to have them separate. And they're managed, it seems like they're managed by different things. But anyway, that's cool. So let's just go here. What I'm gonna do, I'm gonna change the branch to flight deploy here for now. So I can just commit this and push it. And here's the branch we have to choose from as well. How to refresh. So we need to refresh this now. It should be in there. So that's in a new branch. It's right there. Because I don't want to refresh this because I don't want to lose this. Now, I guess it doesn't matter because we've got it. So if we go Rails, and then we just go here, flight control deploy. There we go. Okay, so let's create the project now. So that's reasonably straightforward. Okay, let's see what happens. So it's going to provision this for us. We're going to spend some cash, looks like. We'll have to just figure out how to do the domains and the certificates, because this is now you're getting a little bit more into the weeds, right? You're getting a bit more down a few levels here. Usually Fly takes care of a lot of stuff for us, which is why it's so good and highly recommend it. We're now in a specific use case, right, where we need a little bit more control. So we need to know a few more things. Like I'm a little bit rusty, like, to be honest, on this stuff, but we just will work through it and then get to where we need to be. But hopefully, like you can see, this is doing it all for us. So now what this will handle is whenever we push, it will do the deploys and rollouts and everything. We don't have to worry about all that stuff. and it's setting up all the infra for us. So while it's loading, we can just click on environments here. You can see it's provisioning each one of these. So if we click on this, see the logs when they're ready. So it's busy provisioning the server. It's just waiting, and then the workers, the same. So it's quite cool. We get a lot of insights here into what's going on. So if we jump to CloudFormation in the correct region here, we can actually see now. So this deployed the VPC, and now this is deploying the worker here. So the production one's done. You can see it's created internet gateway, subnets, VPC, and then this one's doing the workers, the same thing. So realistically, this guy should almost be done. Now provisioning in AWS always takes way longer than actually spooling up or creating new ones. So there's the route. So what has it done? It's created a route, internet gateway, security group. Another cool thing is here too, if you click on that, that's going to take us to the actual resource, right? Boom, right there. So it's very cool. You actually see every resource. So if you need to tweak it or change it, you can. Or if you want to check it out in the AWS UI, you can do that. So there, that's all done. And this has got one more left, just the auto scaling group. So you should be done. It still says it's got some, it's doing some stuff, which is interesting. Here's the config. So you can't change it. But you can, I imagine, change some of this other stuff. The environment variables we'd have to change. Domains, and then the AWS resources. Destroy the whole service. So that's really cool. I just wonder what it's still doing. Like where do we, okay, here, so that now it's, okay, so it's created the production environment and now it's setting up the app. So it's creating the load balancer here, the roles, the code build project, the repo. Like this is a lot of work. Like if you were to do this by yourself, this would take you so long to do. It's doing a little S3 bucket. So if we go in S3, you can see the buckets here that it's created. Variables. It's busy doing all its work here. Launch template, task definition, load balancer. So it's coming along. All right, we're in business. So you can see the CloudFormation stack's done. All our resources are complete. Now flight control's moved into the building stage. Now we're probably gonna have some problems here because realistically, do we click on this one? Here we go. We're gonna have images. We're gonna have problems because none of the config, like we haven't set environment variables. They haven't set any of that because there's not enough EC2 quota. Code build, login succeeded. Cool. So it's busy building a Docker image, which we're used to. So that's great. And it all seems to be going through properly. So that's awesome. So it's busy building everything there. So we'll let that build and then deploy, but yeah, we're gonna have lots of issues, but that's it. So now we've created some infra and we're deploying. All right, so we've got a new build going on here. So I just had to jump into environment settings, environment variables, and define some envars just to get the build happening. We need this font awesome token for our Docker image to build. And then we've added these other keys, which is nice. And the cool thing about using Rails credentials obviously is that we don't have to have a whole list of environment variables. We have a whole bunch inside the credentials files, all encrypted and using the master key to read those, sorry. So we'll just let those run and build and do their thing. And then we'll check in a few seconds or minutes, I should say. Awesome. So another cool thing, like I like this. You get to see inside the box. So it's not a black box. So you got code build running. You can see here we've got a succeeded run for the Rails app. So if we jump back in here, we should see the Rails app is now deploying. So it's done the build, right? And you can see all the logs, which is awesome. And now it's deploying it, okay? So it's very cool. I like this about flight control. Like, it's when you want to step up in complexity, you need to. You don't have to go all the way just to manage it all in AWS, but you can use their product here. So I saw this a few years ago and did a video on it, and I really liked it. And thankfully, today we're going to try it. So hopefully we can get it all the way across the line. So we still need to do like the domain name and set up the SSL certificates, and then we have to redirect Route 53 here so that our main app works. But what we'll probably do is put on a subdomain just to begin, or a different domain, just so we can test it and make sure everything works. And then from there we can move completely over if we need to. Obviously there's a little bit more of an increase in cost because we're running a few more servers, but it is more powerful. So that's cool. And it's very easy to change these, because what we probably will need to pump up the memory, but also the storage, or the temporary storage, we'll need to do that on there too. So hopefully we can do all that here, and I'm imagining we can, because we are controlling our instances directly. So we'll keep going and see how we go.